video, we're going to talk about how we can find resultant vectors with the parallelogram method. And this is IXL U.6. In the last video, we talked about using the triangle method. So we can use the triangle method if we have a terminal point for one vector that lines up with the initial point of another vector. And if that's the case, then we can just simply start at the initial point of vector A and have our terminal point at the terminal point of vector B, completing the triangle. But what if we don't have a terminal and initial point lining up? What if instead we have shared initial points? We can see that right there where I'm highlighting that in red. If the initial points are the same, in that case, we can't use the triangle method, but we can use what's known as the parallelogram method. And this is what it says. The parallelogram method says that if two vectors have the same initial point, then we can consider the parallelogram with vector, for what I've drawn, vector A and vector B as adjacent sides. And their sum is the diagonal of the parallelogram with the same initial point. So what does that mean? Well, remember, a parallelogram is four-sided with parallel sides. So in yellow here, I have basically copied vector B at the end of vector A drawn over here. That would be the same parallel side, and then I've done a replica of side A over here, vector A, to make another side here. That would be completing the parallelogram. And where the corner is, where those meet, that is going to be the terminal point for my resultant vector. So in green, you can see here, I just need to draw that diagonal, and the diagonal line there is going to be my resultant vector. So let's try this out. Let's try a few IXLs. So how do I do this? Well, what I do is when I'm looking at this IXL, I need to find one of the sides of my parallelogram. I don't actually need to draw the whole parallelogram, because if I can draw one side, then I can see where that side is going to end, where is that corner point going to be. So I'm simply going to choose one of the vectors to replicate. So in this case, I'm just going to choose R. I could choose either one. That's just the one I'm choosing. And I need to see what is my horizontal change and what is my vertical change, okay? So my horizontal change starting at the initial point of R is 1, 2, 3, 4. So I go to the right 4, and it's a vertical change of 1, 2, 3, 4, 5, 6, 7. So I go up 7. So in order to draw my parallelogram, I'm going to start at the terminal point of S, so where my side would start. And starting there, I'm going to count a horizontal change of 4, 1, 2, 3, 4, and a vertical change of 7, 1, 2, 3, 4, 5, 6, 7. And for now, just ignore the green graph that it's graphing on there for you. But that goes up to there, right there. So what I've just drawn is given me the guidelines of where my vector is going to go. So I'm going to, or not my vector, my other side, I guess. So I'm going to draw that hypothetical side in. Okay, so now that I've done that, we can see that that side would end at this point right there. Okay, so you can see how I'm beginning to draw this parallelogram. So now all I need to do is graph my vector. Remember, it's going to share the same initial point, and its terminal point is going to be what the corner of the parallelogram would be. So I just tapped that shared corner spot where it would be, and that's my resultant vector. Let's look at one more quick example here so you guys can see different ways that we could do this, okay? So let's look at this one here. So in this case, again, I'm just going to choose one of the vectors. This time I'm going to choose vector Y, so I need to know my horizontal and vertical change. So to find that, I always start at its initial point. Vertical 1, 2, 3, 4. So vertically it goes down 4, and it goes to the right 1. So now I'm going to erase that so I don't get it too messy here. Now I'll start here, and I'm going to go horizontal to the right 1 and down 1, 2, 3, 4. So that means my side would be just like that. That would be my side that's parallel to side y, to vector y. So we'll try to erase some of that there. Okay, so now I'm ready to do my vector. My initial point is the same, so I start out with my, let's drag that initial point at the same as vector x and y, and my terminal point is going to be where the corner would be if I drew my parallelogram. So that's that point down there, and that's going to be my resultant vector. And that's it. That's all there is to it.